In this video, we're going to add and subtract rational expressions with common denominators. Now, a couple of funny little things is common denominator is also often written as like denominator. The terms are used interchangeably. So remember that a rational expression is just a fraction with a polynomial. So to begin, let's do a quick review. Let's review. Let's try this. We'll add and then we'll subtract. So the problem would read simplify 1/14 plus 5/14. And I'm not going to rewrite it, I'm just going to keep going. When you add fractions, notice this, they have a like denominator, or they match, matching. Let's use that. They have, well, use like, matching. So I have matching or like denominators. This is important. In the next lesson, we'll be looking at how do we handle this when they don't. So matching or like denominators. That means that all you have to do is just add the numerators. So I'd add 1 plus 5. The denominator stays the same. Well, remember that 1 plus 5, that's 6 over 14. And then we always want to check. And if we can reduce this or simplify more, we should. So simplify more. And we've been practicing this. So we said that 6 in its prime factorization is 2 times 3. 14 is 2 times 7. I have 2's that are common, so what I could do then is my 2's would cancel, and I'm left with the answer then of 3/7. Okay. Let's try another one. Simplify. Let's try this. How about 7/15 minus 2/15? Okay, again, they have like denominators, so we can proceed just working with the numerators, denominators. So let's move forward. This becomes 7 minus 2, just like in the above where we just wrote the addition, now we just write the subtraction over 15. Well, 7 minus 2 is 5 over 15. And then notice this, 5 is a prime number, so it can't be factored. But 15 has a 5 times 3. So the 5's are going to cancel. So you have to remember that when you cancel the 5's, there's always an implied 1 left behind. So we have our 1 left over, and so I could more simply write this as 1/3. Okay, let's try this. We're going to have 2 examples today. The first one is simplify. Three x plus 5 over 2x minus 3 minus x minus 3 over 2x minus 3. Okay, the first thing we know is, again, that we have matching denominators, or we'll use it another term the other way. You'll hear it as common denominators. Okay, so working from that, let's go from here. Now, if we look at what we did above, this says we subtract the second numerator from the first. Well, here's what you have to be careful of. It says you have to subtract the whole numerator. So let's do it this way. I have 3x plus 5. And remember, that is a number, and I'm going to subtract from it x minus 3. That is also a number. Our denominator remains the same. I'm going to come down here. This means there's always an implied -1 there, so we have to distribute the -1. And when we do that, we get 3x plus 5 minus an x plus 3. It changes the sign on everything inside the parentheses. Now I combine like terms. So 3x minus an x is 2x. 5 and 3 is 8. And the denominator stays the same. Now, if you could, this is perfectly acceptable. Or, if you wanted, you could always factor the numerator into 2 times x plus 4. And notice that our denominator, it doesn't factor. It's just going to be 2x minus 3. So if you wanted to go one step further, you could write it this way, which is also acceptable. And I write this because sometimes in the answers you'll see it in factored form, and sometimes it'll be left in polynomial form. And you'll need to be able to move your results back and forth between the two. Okay, let's try one more example is in order. And this one's kind of subtle, but I think you'll like this. Simplify. The problem reads this way: 1 over x minus 2. Oops, sorry. Got an extra sign, dot there. X minus 2 plus 1 over 2 minus x. Okay, well, wait a minute. These are not like denominators. But here's where we have to look at it. Let's take a closer look. Let's take a look at this second fraction here. I'm going to write it down here as 1 over 2 minus x. Now we saw this earlier in a couple of videos back, because the second fraction is 2 minus x, which sure, it's just the wrong signs on the denominator. So let's try this. What happens, and it may not work, but let's try. What happens if I factor a negative 1 from the denominator? Then I have a minus 2 plus an x. And then remember that addition is commutative, meaning you can change the order. So I could write it as minus 2 plus x, or I could write it as x minus 2. Now look at this. This is what we need. This is the match. However, we still have this. And what we said is you can write a fraction, for example. You could write the fraction of negative 1/2 as negative 1 over positive 2, or you could write it as 1 over negative 2. You can do all three ways. It's the same thing. So we already have, now let's look closely here. Notice in the original problem that we already have a symbol in this front position. And then if you look again, we see that we're down here. So we're left with going up to here. So that's what we're going to do. We're going to move the minus sign from the denominator into the numerator as negative 1 over x minus 2. Now we have like fractions. So let's try again. So now the problem becomes 1 over x minus 2 plus, and I'm going to just write the original problem so we can see its progression. So I have 1 over x minus 2, and I have my plus sign, and then now this second fraction here, well, we said that's just the same as this result up here. So now we're going to use that result. Negative 1 over x minus 2. The fractions match, or the denominators match, so I can write this as 1 minus 1 over x minus 2. 1 minus 1, well, that's just 0. And we said that if 0 is in the numerator, then the answer is very simply 0. And that is how you add and subtract rational expressions. Thanks for watching.